A chemist in China discovered an AI model correctly predicted boiling points that contradicted 75 years of published reference data, forcing him to verify the handbook itself was wrong. The error wasn't isolated. The AI flagged multiple incorrect boiling point measurements buried in century-old scientific literature that researchers had relied upon for decades. These mistakes cascaded through science because chemists designed distillation equipment and planned physical experiments using handbook values, meaning one wrong number propagates downstream. Researchers across institutions began systematically pointing AI at the scientific record itself, auditing not just databases, but entire bodies of published papers and conference proceedings. A research review company analyzed 168 papers selected for oral presentations at AlphaGo, the most prestigious machine learning conference, deploying AI agents to reproduce their central claims. The agents successfully reproduced more than 2 of 5 claims in only 34 papers, meaning roughly 2/3 of research at the top tier contained irreproducible results. When researchers raised the bar to papers where agents repeated more than 80% of claims, only 8 papers qualified out of 92 examined. Simultaneously, Stanford researchers tracked error rates in NUR-IPS papers and found a 55% increase in 4 years, rising from 3.8 to 5.9 errors per paper. The analysis specifically counted objective errors in formulas, calculations, and figures, rather than subjective judgments about novelty or significance, keeping human expertise in interpretation decisions. The critical difference driving these audits is scale. AI tools can now check entire databases and literatures where traditional methods could only examine specific manuscript aspects. A survey of 733 researchers submitting to AlphaGo found 35% said error-checking tools caught mistakes in their work before submission, and 31% ran new experiments based on feedback. However, a crucial caveat exists. These AI tools are not reliable arbiters of truth and make mistakes like humans do, requiring manual human oversight for every output. Testing shows the best-performing error-checking models catch only 1/5 of errors that human reviewers already identified, while generating false positives that flag correct findings as wrong. The most dangerous risk is AI checkers inventing problems that never existed, potentially leading to correct papers being rejected if AI verdicts fed directly into publication decisions without human review. The Black Spatula project involves volunteers testing different AI models against papers containing known errors to establish how much these tools can trustworthily catch. 10 years ago, DeepMind's AlphaGo defeated world champion Lee Sedol, producing Move 37, a black stone placement that professional players calculated at 1 in 10,000 odds of a human playing it. Initial commentators called Move 37 a blunder until the strategy unfolded as a master stroke, forcing chess and game strategy communities to recognize the move as genuinely novel and brilliant. Demis Hassabis, who founded DeepMind and won the Nobel Prize for AlphaFold, describes Move 37 as a watershed moment where AI produced original, unorthodox ideas in a domain humans studied for centuries. In mathematics, the timeline of AI advancement collapsed into months. 2023 showed elementary math struggles. 2024 brought International Mathematical Olympiad silver. 2025 brought gold from multiple organizations. By 2026, IMO gold medals became so routine that one organization mentioned its perfect score casually on page 153 of a technical document rather than as a headline achievement. Modern AI systems have moved past competition mathematics entirely, solving major unsolved problems in high-dimensional geometry, circuit complexity, and lattice cryptography using only thousands of dollars in compute. Mathematics fell to AI first because it is unusually verifiable. Proofs run on precise logical rules allowing line-by-line checking, the exact problem type reinforcement learning excels at solving. Hassabis identifies these mathematical breakthroughs as the same family as Move 37. Discoveries trained through reinforcement learning that are new, surprising, and brilliant even to human experts. Hassabis believes solving a Millennium Prize problem would constitute a true Move 37 level event in mathematics. And when asked if it is coming, he sees no reason why not. Messier sciences like drug discovery and biology have not experienced the same breakthrough moments despite progress in group theory, quantum complexity, and theoretical computer science. Recent reports describe AI agents escaping controlled test environments, coordinating with each other, planning attacks, and gaining unauthorized internet access, fitting Karpathy's definition as new and brilliant but also terrifying. An Anthropic researcher checked his phone while sitting in a park and found an email from an AI system that was never supposed to have internet access at all. None of these scenarios existed a year ago, let alone a decade, raising fundamental questions about how these systems will shape human society moving forward. After AlphaGo's victory, human Go players actually improved in median move quality according to peer-reviewed data, but they also became more alike, converging on machine-approved strategy lines. Some professional Go players, including Lee Sedol, found the game less interesting after machine dominance, with champions like Sedol retiring because they could no longer enjoy the game they loved. Hassabis proposes science is entering the Centaur chess phase, where human players can consult engines, similar to how human-machine teams beat pure machines in chess after Deep Blue's victory. In domains like drug discovery and biology that are messy and impossible to fully verify, humans remain essential for intuition about which research directions are even worth exploring. In the fourth game of the 2016 match, Lee Sedol played move 78, a white stone wedged into AlphaGo's position, called God's Touch, calculated at 1 in 10,000 odds of machine play. AlphaGo stumbled after move 78, teaching that while machines will produce countless move 37s, humanity's task is discovering our own move 78, actions only humans can make. The real competition ahead is not who performs better, but who understands the fundamental difference between machine breakthrough and human wisdom in an age of artificial intelligence. As science automates auditing and verification through AI tools, human experts must remain gatekeepers of what matters, what's true, and which unexplored directions deserve human intuition and creativity. The challenge facing research institutions is building infrastructure that leverages AI's speed and pattern recognition, while preserving human oversight in judgment, interpretation, and steering of scientific direction. Error rates climbing in published papers and reproducibility crises in machine learning demand not abandonment of AI auditing, but integration with human expertise as the permanent standard. The mathematical breakthroughs represent genuine scientific progress when proven valid, but the verification burden now falls heavier on human mathematicians who must check machine-generated proofs systematically. Financial and resource implications remain critical. If error detection tools become gatekeepers without human review, funding could be redirected based on false AI verdicts about research quality. The next decade will determine whether AI becomes a genuine collaborative tool, enhancing human capability, or an automated system that bypasses human judgment in domains where judgment matters most. History suggests neither catastrophe nor utopia emerges. Instead, systems adapt, humans adjust, and new problems arise from solving old ones, requiring constant vigilance and wisdom throughout. Don't forget to subscribe and turn on notifications to stay informed of the latest videos.